Today I'm working on ways to improve our sintering techniques. So this is my bench furnace setup, and this is mostly just for testing the debinding phase. But maybe I'll get lucky and we can actually sinter in the test tube. So I have my parts in there, it's sealed. I just have that as a bubble counter so I can tell if gas is still leaving the system, which it is, as you can see. And I have a tube that I can inject gases. It's the one that goes all the way to the end. You can kind of see it in the middle. It's a cut-off pipette. So let's see what we can learn. This first test was very informative, but kind of had a fatal flaw. As the gases evaporated out of the part, they condensed on the Pyrex around the piece. So it just condensed onto the Pyrex, and then as the Pyrex got hot, it burnt. So it slowly just became carbon, and I was no longer able to see the part. So we'll move on to the next test where I will pass more gas through it so we can try to keep the glass clean so that we can see what's going on. Here's my second test with desktop debinding in a test tube. So this time, I've decided to actually force air into the system with this small pump. So it'll blow it in here. We'll add heat with the Bunsen burner. I have a temperature probe in there. And what I'm hoping is that we remove the off-gassing as it's produced and it doesn't have time to condense anywhere. I'm just trying to see if we can come up with a much cleaner debound part after this phase of the process. The piece of the 3D print that I have in here is stainless steel 316L, but that's really not important for this test. This is purely focused on the debinding process, which is the removal of the thermopolymer that keeps the part together during 3D printing. The polymers in the binder and filament are made of sort of a series of different materials that turn to a gas at different temperatures. So what I'm doing now is I'm slowly heating up the part in a test tube and then just watching the gases that come off and at what temperature. And this is kind of interesting. You'll see what looks like smoke, but it's not actually smoke. It's a vapor, so it's not a combustion product. So this is what I'm talking about. So we're at 664 Fahrenheit, and it's got off-gassing pretty aggressively at this point. And you can't see the printed part in the bottom, but it hasn't changed shape. It's going through a period of densification and debinding right now. This is test tube debinding setup version 2. Learned a lot from the first try. I decided to implement some improvements. This is what I'm talking about. First try, and it isn't sealed exactly perfectly, but good enough. I also realized that things could work a lot better if I learned some quick glass blowing, so I literally went out to YouTube and did some quick hacks on working with Pyrex, so you'll have to pardon my awful looking joints, but I think they're going to work. This version of the test, I have air coming off the compressor, is a small cheap regulator, going into a gauge so that I can fine tune how much air is passing through the system. Goes over to here, goes through my awesome work, and here's the piece that I'll be debinding. This is a chunk of bronze. I don't expect to get to sintering temperatures, although I think we're going to get close in the future. And I have some quartz glass tubing that I'm going to use, and we'll try it with induction, maybe even microwave. So the gases pass out of here. Through the vent hole, I put in my thermocouple. So the thermocouple goes through the vent, and it's sitting right under the part. One last minute change. I decided that I wanted the temperature probe to be inside of the part. So it's still reading 216. So I just took the thermocouple, come on, focus, heated up just a few strands of
filament with a small torch and just melted it into roughly the center of the part. So we're coming up on 700 degrees Fahrenheit, and it's showing visible signs of oxidation. Isn't terrible, if I can get it to focus, but kind of interesting. So this is just air off the compressor. I'm going to do the same test again, but next time I'm going to run argon through it. We're at 1037F, and the part looks like a pile of cupric oxide. This looks exactly like what we expect to see in a failed, come out and focus. This is what we expect to see in a failed sintering attempt. So this is pretty interesting. So like I said before, now I'm going to try the same test, but with oxygen instead of just, or I mean, with argon instead of air. Next setup of the test, this one we have, I think, pure argon. Yes.
This test went extremely well. Well enough that I decided to make another one. And the next one, I'm going to be much more formal about how I build the test apparatus, how I manage gas, oxygen, airflow, and all of that good stuff. So I hope this was interesting. Please leave comments on how I can improve these videos. I'm a beginner at this, but getting better. Just kind of throwing myself at it to see how it goes. Let's give it a try and look for test tube debind video number 2. I'll try to get that out as quickly as I can. I have most of it filmed already.